Assalamualaikum. Today we like to present our group project, which is to predict analysis on COVID-19 world vaccination progress through data mining. Okay. So now I will introduce you to our team member for this group project. Our group leader Bishrum bin Abdullah. Second is me, Abdul Mutakim bin Muhammad Mahidin. Third member Muhammad Imran bin Sahram. And finally Akmal Al-Arkib bin Muhammad Azuddin. Now we proceed with a brief introduction of the dataset for this project. Okay. The dataset that we choose for this project is COVID-19 vaccination progress. The dataset has been retrieved from the official open datasite Kaggle. The dataset was produced by collecting vaccination progress data around the world. It is collected through vaccination report recorded in the different countries. The purpose for this dataset is to speed up the vaccination progress in the most efficient way. The dataset contains 2,598 instant and 15 attributes, including numerical and nominal data, and a few missing values.
Okay, next I will continue on data understanding. For this dataset, there are a total of 15 attributes, which are 9 numeric attributes and 6 nominal attributes. As you can see, these slides contain all the attributes that are available in the dataset, such as people vaccinated and total vaccination for numeric attribute, and country and date for nominal attribute. Okay, next, this table shows the list of numeric attribute of the dataset. For the numeric attribute, there are minimum, maximum, mean and standard deviation for each of the attribute. For nominal attribute, this is the nominal attribute of the dataset, and this table contains its value for each attribute. This is the data visualization before data balancing for this dataset. The dataset class indicates that the data is unbalanced. As for result, the data balancing is required. To do data balancing, first we need to pick an attribute, and in this case, we pick the date of vaccination that can be grouped into 4 quartiles by using merge many values filters. Label month 1 until 3 has been combined and labeled as Q1. Label 4 until 6 has been combined and labeled as Q2. For label month 7 until 9, it has been combined and labeled as Q3. And lastly, label month 10 until 12 has been combined and labeled as Q4. Then, we need to replace missing value. By using replace missing value filter, we can replace null values in the dataset into randomly chosen set of numbers to improve the quality of information. There are multiple attributes with missing value, so we need to use replace missing value filter to remove the missing value. This is the result of after we apply replace missing value filter. On the left, you can see before we apply the filter, there are null values detected on the dataset. And on the right, after we apply the filter, the null value has been replaced. Okay, next, detecting outlier. After we have done replacing missing values, we need to detect and remove outliers. Firstly, to detect any outliers in the dataset, we use interquartile range filter to set range value for outliers. This is the result after applying interquartile range filter. We can see that we have detected an outliers and we need to remove it. There are 360 outliers detected in the dataset. Then we need to remove outlier. To remove outlier, we use remove with value filter to remove outlier and apply to the dataset. Okay, this is for removing outlier. On the left, we can see before we have 360 outliers, and on the right, we can see after applying the filter, outlier has not been detected as we have 0 outliers.
We now proceeding with the data preparation with its transformation. In the process, we will apply the normalization filter on WEKA to prevent when the distribution of data is too big to recognize. As you can see, the minimum value will be 0 and the maximum value will be 1. As you can see, this is the result before and after applying the normalized filter. The attribute for total vaccination, people vaccinated, and the people fully vaccinated has been normalized by turning into the minimum and maximum value to 1 and 0. Okay, we now continue with the discretization process. In this part, the attribute people fully vaccinated per 100 is required to be discretized because it contains 875 distinct numeric values. Okay. To start, we can use the discretize filter in WEKA and set the bin number to the 5. Because we want to separate into 5 categories of the values, we use 20%, 40%, 60%, and 100%. As you can see, this is the result before and after applying the discretize filter with 5 bins. The value has been separated into the 5 range of number in the 5 different categories. These 5 bins will be renamed later. The attribute that has been discretized need to be renamed, so it be easier to recognize the category. By using rename nominal value filter, we can rename the 5 bin that has been unrecognized label. Okay, in the filter properties, the new label for each bin are renamed accordingly for 20%, 40%, 60%, 80%, and 100%. As you can see, this is the result before and after applying the rename nominal value filter with 5 bins that has been labeled with a new one. As a result, it be easier to recognize data with a new label set.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran and I'm going to present about the model, development and evaluation of this project. This project is going to be using the J48 algorithm because most of the model of J48 will generate accurate classification result. The vaccination progress of the Southeast Asian was using a model of fold K equals to 20, fold K equals to 20, and percentage split. The percentage split is 70 to 30, and split 80 to 20%. The cross-validation for K equals to 10 shows that correctly classified instances equals to 2,184 instances, which is equals to 97.5871% of the classified instances. The cross-validation for K equals to 20 result shows correctly classified instances equals to 2,184 and the percentage is 97.5871%. The percentages split test of 70 to 30% has resulted in 658 incorrectly classified instances, which equals to 98.0626%. The percentages split for 80 to 20% has resulted in 440 correctly classified instances, which is equal to 98.2143, which is a slightly increase from the 70 to 30% percentage split. The diagram shows the decision tree, which is the number of leaf equals to 33 and the size of the tree equals to 55.
For data reduction is to reduce volume of the original dataset. The data reduction can improve the accuracy and reduce time taken to build the model. So, the first step is to make a data reduction by go to section on the select attribute tab, choose the info gain attribute and select the class. The result will show based on rank of the data supervised class. We can see that there are number of rank. The higher the number of rank, the higher of the attribute contribution. For the C vaccine progress, we remove the least contribute data such as date, source name, daily vaccination on the pre-process tab. Next, I will show the result of the reduced data. This is a cross-validation K10 of the reduced data. We can see here the accuracy is 95.8105 and the incorrectly classified is 2.1895%. For the cross-validation K20, the accuracy is 97.88999%. The incorrectly classified is 2.1001%. For the percentage split, the accuracy is 98.0626 and the incorrectly classified is 1.9374%. For the percentage split 80-20, the accuracy is 98.4375% and the incorrectly classified is 1.5625. This is the decision tree after the data reduction. We can see that the number of tree and leaf also reduced after reduce the data. The bar chart show the comparison of a J48 model that compare between the full data set and the reduced data set. From here, the accuracy of 4K10 is increased after make a data reduction. K20 also have the improvement in the data accuracy. For the split 730 has an improvement and reduction in terms of accuracy of the data. For 80-20, we can see that there are significant improvement in accuracy of the data. So we can conclude that on the bar chart, the most accurate model is 80-20 after the data reduced. That's all. Thank you.